talk a little bit about balanced mix design approach, and maybe just a little different way of looking at how we design our mixes, and share a little bit about what's been going on, not only in Texas, but across the country. So here's my table of contents. First, I'm going to share some thoughts with you that you probably already know. Then I'm going to tell you that we're not alone in these thoughts. I'll share a little bit of history with you, and then I'm going to ask you some questions, but I don't expect you to answer. We've all out of school, and this is not a test. So, and then I'm going to state the obvious, and then I'll share some ideas with you and give you some examples to go with them, and then hopefully we can start to build on some of these ideas. So some initial thoughts, and you've probably heard this already. Dry mixes are prevalent in our industry. We know that. It's been going on for a while. That pendulum, I think, that swings back and forth is stuck over there on the dry mix side. So we know that's an issue. But restrictive specifications and general notes aren't long-term solutions. You know, when I see a lot of general notes and plans, that just means that what we're specifying as far as what we put in our specifications don't match up to the performance that we get out in the roadway and what we expect out of the mixes. Lowering in design and raising lab molded densities will only help so much. We do that, we try that. It works to a certain extent, but eventually, you know, contractors are smart. They're going to figure out a way to be able to keep costs down as much as possible. Continuing to increase binder replacement, and by binder replacement I mean recycled materials, without addressing mixed performance is not sustainable. We've learned our lesson. We're trying to figure out the best way to do that and still be able to use some of these recycled materials. What we need to do is increase our understanding of these factors which drive mix performance to help us better optimize our mixes. This is a national problem. Researchers across the country are looking at better ways to design longer lasting pavements. These are issues that we all talk about. At NCAT, which has a test track at Auburn University, several test sections at the track are dedicated to investing in long-term pavement performance. There's papers out there, there's workshops, a lot of stuff's going on. In fact, NAPA, which is the National Asphalt Pavement Association, recently created a pavement performance task group in response to concerns over states' issues with pavement performance. So this is going on across the country. All these states are searching for solutions. If you look at InDesign, and we talked about lowering InDesign, all the states that you see up here in the tan color are looking to lower their gyrations to be able to get more asphalt into their mixes. Some of them are trying to keep the old gyration levels that they have, but they're also trying to incorporate new and lower ones to be able to get a little more asphalt in the mix. And I know some states, I think they're in competition who can have the most gyration levels. I think Iowa wins the cake. I think they have 9 different gyration levels, which is ridiculous, but that's okay. That's their thing. And some states like Texas, we've tried to go to a single gyration level, which is probably a little more appropriate and definitely a lot more simpler. If you look at the evolution of mixed designs over the years, you know, most of these were recipes. They would just say, you put these recipes together, you put this aggregate and this asphalt together, and you come up with a mix that you're going to use out on the roadway. Some of the mixed designs later on started to try to incorporate some kind of performance testing. And as John said, when we got to Super Pave, this was the idea. Have level 1 to do volumetrics, level 2 and 3 were going to be all your performance testing, but it never got implemented. One of the things that I wanted to note out of all this is that over the years, binder content's gotten lower and lower. And so what has that done? It's basically given us less durability and a decrease in our performance level of our mixes. Some questions that we need to ask ourselves as we go forward, and we've been already asking these as far as on the research side. Is Super Pave the answer? Be honest with you, I think it's a step in the right direction, but I don't think it's the ultimate answer. All these other states that John mentioned, they're already doing super paved mixes. They're having the same problems that we're having. So, yeah, it's a step in the right direction. I think there's a lot of properties within that. It gives us a lot of freedom to design mixes, but I don't think it's the ultimate answer. Is getting rid of wrap and RAS the answer? Not really. I think what we have to do is be able to find a way to utilize materials like wrap and RAS and other recycled materials properly. No, in other words, I used to say, use them, don't abuse them, right? And that's just like with anything else. Is disallowing modifiers like REOB and PPA, is that the answer? Right now we're limiting those, but you know what? They've been used successfully in mixes for 20 plus years. So we know that they can be used right. It's having some kind of performance test to look at the binders themselves to say, are these materials compatible? And is doing things the way we've always done them the answer? Of course not. We've got to, things have changed, our situation's changed, traffic changed. There's so many changes that have gone on, we've got to change with it. And what about traffic and climate? When I look at our design procedure, I ask myself, are universal volumetrics controlling designs without regard to traffic and climate? So following the recipe, really most of what we do is recipe driven. It's driven by volumetric designs based on a history of what we think works. The problem is recipe specs have become convoluted and confounded over time with specified items and general notes that compete against each other to achieve the desired goals. In other words, we add things in, but we don't take anything out. And as looking at our specs, all of our hot mix specs are 30, 40 pages long, very complicated. And when we do that, innovation becomes stifled by our own specs. The answer is to eliminate the restrictions and focus on performance. So let's look at a little better approach. Let's stop using the recipe to determine if the cake is good. We need to define our expectations and open up the recipe to meet the end result. What defines a good cake, right? If it tastes good. What defines a good mix? Lasting performance. And I go back to expectations. If I'm at Three Forks, this is what I expect. In other words, as a good cake. When I look at it, I say, okay, that's something that I want. If I'm on a camping trip, this is more what I expect. This is performance. So align your expectations. Optimize mixed design approach fundamental points. Use what works, eliminate what doesn't, and be simple and practical. And as someone told me, good doesn't have to be complicated, and complicated isn't always good. So what we need and what they want, really what we need from our designs is we need to design for performance, not economics. And I think we've had the cart before the horse for a while now. And I know there was a time when we had to cut back and we had a limited budget, and it was, how can we save money? How can we cut back? But really what we did was put the cart before the horse, and we started designing around economics only and stopped designing around performance. And contractors, I've talked to contractors around the state. I've talked to a lot of districts. We don't mind spending a little more money for performance. But you know what contractors want? They want a level playing field. As long as we raise the bar for everybody, then they're going to be fine with that. I think they've come to that realization. But like John said earlier, if you put a super paved C versus a dense graded C as two side-by-side mixes, I'm going to choose the cheaper one every time. So what we have to do is raise that bar and keep that level playing field for contractors. So what is a balanced mixed design? And you're probably going to hear me say the word balanced and optimized. They're kind of interchangeable. Some folks around the country call it optimized mixed design. Some call it balanced mixed design. In the dictionary, optimize is to make the best or most effective use of a situation, an opportunity, a resource. Balance is to being in proper arrangement or adjustment, proportion. For a mix design, it's to optimize the mix and provide needed performance and balance between stability and durability. So when we look at it from a mix design point, these are probably the four keys that kind of make up any mix design framework. You've got material selection, you've got to optimize or your job mix formula. Then there's mix performance evaluation, and that's probably the big key that's been missing for the most part. And then the workability. You've got to be able to produce and work the mix and place it in the field. So let's focus on this part right here just for a second. The stability, which is, for us, it's the Hamburg, and it's an indicator of rutting resistance. And then there's durability, and that's an indicator of cracking resistance. That's right now is our overlay test. We are looking at the overlay test as well as some other cracking tests. I have to admit, I'll just be honest with you, that is the weak link in performance testing, and that's not only for Texas, but everywhere around the country. They know that the durability test is the weak link, and we're trying to find answers, but it depends on what type. If you talk about cracking tests, it depends on what type of cracking test and what type of cracks that you're trying to address. So we'll talk a little more about that in just a moment. But right now, we've got a lot of work going on with the overlay test. We're looking at some other tests as well. This is what the whole framework looks like. And it can get a little bit complicated, but really, let me just touch on a couple of these points real quick and just talk about some of these things, because right now, within the last year, we've had a lot of issues with binders and the quality of binders. And we just kind of started to figure out that some of our issues related to mixes had to do with binder quality. We never did really put the finger on it at the time, but then we started to figure out that there's some things getting added, like REOBs, which are recycled engine oil bottoms, or PPA, which is polyphosphoric acid. Those were things to help meet PG specification requirements, weren't necessarily that good for the asphalt, or they just weren't compatible with the asphalts that were out there. And as we did that and we used more recycle, we pulled polymers out, or we're using latex. There's a lot of different things going on. But really, when you think about it, no matter what you use out there, you've got to make sure that you've got compatibility. And that's really some of the testing that we've come back and done this year to say, are we getting compatibility with all these things we're putting in the asphalt binder? So that's something that we really need to focus on. And with recycled materials, whether it's wrap, brass, ground tire rubber, we need to know what those properties are. We can't just blindly go into a design and go, we're just going to put this in there without really knowing what it is. And I think the thing to take away is, and we talked about this a little earlier in the material, in the construction side, is the binder from the recycled material is never 100%. Some of it's going to be black rock, some of it's going to contribute to the asphalt content of the mixed design. So that's a big question on what that number is, but I think that the idea going in, if you go in with the idea if it's 100%, you're fooling yourself. I just want to talk a little bit about some of the work that TTI has been doing, and this is a job that Fujizo had done with a couple different mixes. And if you look here, the bar is rut depth. And the line here is the overlay test. And I guess what I'm trying to say is you can design mixes. This is an SMA mix. Has 20% wrap here, 5% RAS, manufactured waste, and then 5% RAS tear-offs. You can get better performance in the Hamburg and still get fairly good performance. All these are between 800 and 1,000 cycles on the overlay. There is absolutely a way to design these mixes with recycled materials and still get great performance. You just have to look at both sides and figure out what you're doing. Same thing with a Super Pave mix here. This is a Super Pave mix with 25% wrap and 2% RAS. So a lot of recycle in there. You got, for the most part, you got better or just about the same performance on the Hamburg, and you got all the recycled sections or all the recycled material mixes perform better in the overlay than the control section. So going on to optimizing our JMF, it's good to know, and what John talked about, stone on stone, dense graded, whether you're going to go below, above restricted zone, whether it's gap or open. You just need to have that in mind when you look at the type, when you want to put the material out there. And with binder content, is more always better. I don't know, we talk about getting more asphalt in. I think that's an important concern. But what we have to think about is more always better. There's probably a point of no return on that. And then volumetrics. A lot of people are talking about VMA, increased VMA. That's one area that we really know that gets us more asphalt in the mix. But there's also volume of effective binder. And there's also film thickness. There's a lot of other discussions about other materials that not just AC content, but some of these other volumetric parameters that really give you a good indication. Do I have a good film of thickness of asphalt around that rock? And we've seen this. I've showed this data before from our overlay data. This is some of the stuff that Hassel had put together, Hassel Carrasco in our office. And it tells the story. The more asphalt you put in the mix, the better it's going to do in the overlay. But you got to balance that out with the other side. You got to make sure, you end up with some return on, small increments of improvement, and then all of a sudden you get problems with stability. So you just got to keep that in mind. And then here's the optimized, really the crux of this approach is the mixed performance evaluation and the stability and the durability. And there's more than one way to get there. It's not just Hamburg and overlay. It can be a lot of different things depending on what you're trying to do and depending on the mix and what you're using it for. And these are just some of the tests out here. This is actually the AMPT device with the overlaid. This is the 4-point bending beam. We've used that a lot around the country. This is the semicircular beam test, and there's actually using this is LA abrasion machine, a Canabro, and you just basically take pills in there, throw them in. It's a very simple test, but it gives you an idea of the cohesiveness of the mix. And I'll talk a little bit about what we're doing with limestone rock asphalt in just a sec. And then on the stability side, you've got, of course, the beam stability. Here you've got an APA, asphalt pavement analyzer, Hamburg, and IDT. But we've used a lot of these off and on. We're kind of settled in on which ones we like. But for different mixes, you want what's really going to drive the performance. And you've got to have a balance between both of these. That's really the key. This is some work out of the University of Illinois with Dr. Bill Butler. And this is another cracking test, this DCT fracture energy test. And it basically is measuring the fracture energy versus the Hamburg rut depth. But I like the way this looks because it tells you, it gives you an indication, like for instance, if I've got a high fracture energy and a high Hamburg rut depth, I'm looking over here in this corner, I've got a soft mix. Well, use that to design the reflective crack control. In other words, use that for one of your inner layers for reflective cracking. On the other end, you got stiff mixes. Some of these poor mixes that don't do well on either test, I don't know, maybe you use those for non-surface, low traffic, or temporary use. I mean, there's uses for these different mixes, but I like the way using both tests and categorizing where the mix falls. This is some of the work that we had done a few years ago in our laboratory. And you've got Hamburg over here and overlay over here, and as you add asphalt, you're running both of these tests and you plot basically where they meet these requirements. So if you look at this is a PG 7028. If you look, let's say 10,000 passes on the overlay, 300 cycles on the overlay, 10,000 passes on the Hamburg, you end up with a range of asphalt content between 5.3 and 5.7. So the balance is somewhere in here. Depending on what you use it for, you can lean that direction toward the cracking side or toward the rutting side. This is what we're doing with our limestone rock asphalt. This is another research project, TTI. Cynthia Stockery did a lot of work in this. We had beam stability in the LRA spec for years. It's been in there forever. And it was at 35, and just about everything was passing stability. But what we were still having issues we were just having issues with mix coming apart, having cohesiveness in it. So we started to run Canabro, and through the research found out that when we get above 15 on the Canabro loss, that's where we started to see the mixes come apart more. So we've been recently running a lot of these. This is a type 1 defined mix of LRA, and now all of a sudden we're trying to stay in this area here, and so that we have both stability and we have durability by using both of these tests. So what if we can't get it to balance? Well, there's adjustments that can be made. I mean, I'd like to say, just give a shout out, there's a level 2 mixed design committee that TxAPA has at the Asphalt Pavement Association, made up of a lot of mixed designers around the state. John's on that committee. They let me come and sit in. As you know, most of the TxDOT, we don't design mixes anymore. That fell into the hands of the contractor with QCQA. They're the experts. They're the ones that know what they're doing. So it's nice to kind of sit around and pick their brains and talk to them about that. So I just want to say they're thinking about a lot of these things, and it's nice when they get to share these ideas and we can give those ideas and just turn around and send them out to TxDOT in the industry. So a lot of good work coming out of that committee. And then there's also workability. You know, once you design a mix, is it easy to mix or difficult to design? Does it mix well through the plant? Is production consistent? Is the mix easy or difficult, to compact? And is the mix prone to segregate? There's some mixes out there that they're just very prone to segregate. There's a problem with these mixes, but these are the things we need to talk about with our mixes as we evolve in our mix design process. So some final thoughts. Some form of balanced mix design framework is probably in our future. There's a lot of work on a national level already in progress towards this. It's probably going to involve something around this stability and durability thing with some focus on material selection and workability. Some constraints as I see it, large ships turn slow. We're a big organization, and to be able to make this kind of change is kind of a change in mindset. We still have some issues with durability, like I said, on the overlay, whether that's the test or we're going to use some other cracking test. I think we've made a lot of progress toward coming up with some answers on that. And then as we mentioned in the previous session, the aggregate gravities. Right now, TxDOT does not do aggregate gravities, but if you're going to accurately measure volumetrics, VMA, we're going to have to get back to doing aggregate gravities, and that's a whole nother can of worms that'll be opened up and for discussion. So with that, I just wanted to throw those ideas out to you, and hopefully we'll take away something from that. But anyway, thank you for your time, and you guys enjoy yourself this evening. Right. I'll summarize that. So the question is, Herman's asking, have we come up with any thresholds on what determines what a good mix and what a bad mix is? And I think it depends on our mixes. The TOM mixes are going to behave a little bit different than the SMAs. We made some adjustments. TTI's done some work to establish what those number of cycles are. The Tom mix is probably a little bit higher. The cam mixes are even still higher than that. I think they're still at 750. Um, I think we lowered the Tom to, is it 5 or 3, Tom Scullion? 300. And then the SMA is down to 200. So my biggest concern is our regular mixes, whether that's super pave or dense graded. That's the ones where you get down in that low range, and that's where I struggle with what's a good number. Is it 15 or is it 40 or is it 50? My answer is this. University of Texas El Paso is doing some work where they're looking at a different way to analyze the data. They're not analyzing by the 93% reduction of the first load. They're analyzing by how much a sequential load drops. In other words, when two sequential loads values in load on the cycle go below 5, there was a 5% drop, then that's when it triggers to shut the test off. It's cut down the variability considerably. Now, when they got that under control and they showed me the data, the next question I asked was the question that you asked, Herman, was, can you still differentiate between mixes? And that's the part they're doing now. They've got several mixes that they're evaluating that are good performers and bad performers out there, and that's what we're trying to do, to make sure that we can still differentiate between the good and bad mixes. But I think we're onto something with just a different way to evaluate the data that we're getting from the overlay.
Any other questions?
Yes, Lisa.
I have a comment about your cake analogy and recipe, not relying on the recipe. A cake might taste the same if it's made with butter or less butter, but as it works through your GI tract, it's not going to be the same. And I think we need to always know what's going into the raw materials.
I agree. Lisa talked about what's going in, right? Yes. I agree. We do need to know, and I think it's important that we know what's going in, and I think that's part of what Jerry Peterson's group has gone out to our asphalt producers with the new quality control plan, is they're going to have to tell us what they're putting in their materials. I mean, we do it at every hot mix plant, down to the percentages of what goes in. I think the important thing is, though, regardless of what goes in, it still has to work, and it still has to be compatible. All the materials have to work together.